So section 14.4, and that's where you're adding and subtracting rational expressions with unlike denominators. All right. Okay, so this is number 30. So number 30, you have 5x divided by 6 plus 11x squared divided by 2. So you want to add those two rational expressions. So what's the first step?
On the LCD.
Okay, before you find the LCD, you need to factor the denominators if you can. Okay, but these are monomials, so there's nothing to factor. Now, what is the LCD? 6. So the LCD is 6. So remember, you're going to write two fractions with that denominator. All right, and then you're writing equivalent fractions now. So these denominators are the same, so that's the easy kind. It's not always like that. There's easy kinds. That means that the numerators have to be the same. So this is 5x. All right, but then I have a 2. I want to get a 6. So what is it I got to multiply this 2 by? 3. So what I do to the denominator, though, I've got to do to the numerator. And so the numerator then becomes 33x squared. So once you write equivalent fractions, then you can combine them as one. So my denominator is going to be 6. Now what's the numerator? 5x plus 33x squared. Can I combine anything in the numerator? Nope. So there's your answer. So that's number 30. 34 was this. You have 1 divided by y plus 5 plus 2 divided by 3y. All right, so again, you want to add those rational expressions. You got to find the LCD. Before you find the LCD, you got to factor the denominators. Can you factor these denominators? No. So what's the LCD? Remember, the LCD has to include every factor that's in the denominator. Okay, but let's rewrite it in a better looking way. 3y times y plus 5. Okay, so that's your LCD. So I'm going to write two fractions with that denominator. Okay. All right. Then you're going to write equivalent fractions now. So this is my denominator. This is what I want. What's missing here? What don't you see? 3y. So what I do to the denominator, though, see the green? I don't know if you can see the color green here. You can't. But what I do to the denominator, I got to do to the numerator. So what's the numerator of my equivalent fraction? 3y. Okay, over here, I have 3y. I want this. So what's missing? Y plus 5. So I got to multiply the denominator y plus 5, and what I do to the denominator, I got to do to the numerator. Notice I put that in parentheses, because it's not 2y plus 5 that this is going to end up being. It is not 2y plus 5. This is going to end up being 2y plus 10. That's what it's going to end up being. So make sure you put that in parentheses, because that y plus 5 has to be multiplied by 2. Not the y, but the y plus 5. Now I can write this as one fraction. All right, let's go ahead and distribute this as we go through the process. So it'll be 3y plus what? 2y plus 10. So that's where I'm at. What's the next step? So what do I get in the numerator? 5y plus 10 divided by 3y times y plus 5. Okay? All right, now remember, you want to reduce if you can. So to reduce, you need to factor the numerator. Because it is possible that you could reduce something. So always factor the numerator at the end. The number will already be factored. Now, some of you have a habit, I mentioned this, some of you have a habit of wanting to multiply. Once you get to that point, you want to distribute. Don't do that. Leave it in factored form. There's a couple of you that, for some reason, that could be 10 factors you're gonna want to multiply 10 factors together. You'd be spending an hour doing that. Leave it in factored form. So in terms of the numerator and denominator, which one's in factored form? The denominator. Which one's not in factored form? The numerator. But I can write in factored form because what do they have in common? A 5. So what does it become?
5y plus 2.
Y plus 2 divided by 3y times y plus 5. And now you ask yourself, can I reduce anything?
No.
No. So you're done. This is what I want. Okay? Now you may say, well, why didn't you factor this one? I could have. But the reason I didn't do it was because I knew that the GCF was what here? No. X. But I don't have a factor of x in the denominator, so I left it alone. Same thing here, guys. You could have, if you in your mind, you're noticing that, hey, I can factor out a 5 in my mind, right? But if factoring out a 5 in my mind and I see it, does that help me at all? If factoring out a 5, without writing it down, if factoring out a 5, I notice that doesn't help me. Because nothing can reduce, right? So you could have left your answer like this as well. Okay? But it's always a good idea to write this in factored form just in case you don't see it in your mind. At least you can see it visually on paper. But that's why I didn't factor an x out of here, because there's no x in the denominator. All right, so that's number 34. 36. You have 6 divided by x minus 1. 6 divided by x minus 1. What might you want to do before you find the LCD? Make the 1 a fraction. So that's 1 over 1. Now what's the LCD? X. LCD is x. So now you're going to write 2 fractions with that denominator. Okay. All right, well, these denominators are the same. The first fraction, so 6 over x is equivalent to itself. So I can write this as 6. Okay. I have a 1 here. I want an x. What did I need to multiply this by? Times x. What did I do to the denominator? Did to the numerator. So my numerator is going to be what? And it kind of makes sense that it has to be x divided by itself because I want what number? 1. So this had to be x divided by x. Now I can write as 1 fraction. What's the denominator? What's the numerator? 6 what? 6 minus x. Can I do anything else? Nope. There's your answer. Okay, there's your answer. All right. Let's look at 38. So in 38, you have 9x divided by x minus 10. Subtract x divided by x minus 3. What are you going to do? LCD? All right, and before you do that, you may want to factor the denominators, but I can't. So it's the LCD.
X minus 10 times X minus 3.
Okay, so every factor has to be in your LCD. What are the factor or factors in the first denominator?
X minus 7.
X minus 10. That's your factor, nothing else. What's the other one?
X minus 3.
So it's your LCD.
X minus 2. X minus 3.
All right, so I'm going to write two fractions with that denominator. Okay. What's missing from that first denominator? X minus 3. So I'm going to multiply this by x minus 3, notice the parentheses. I'm going to multiply this also by x minus 3. See this, the parentheses. So notice x minus, the 9x has to be multiplied by x minus 3. Over here in the second fraction, the second rational expression, what's missing? X minus 10. So I'm going to multiply this by x minus 10. And what I do to the denominator, I do to the numerator. Notice the parentheses. So in your mind, in that first numerator, you have 9x times x minus 3, just like this. And in that second numerator, you have x times x minus 10, just like this, right? That's what it looks like. That's where I'm at. What may you want to do next? Okay, so distribute, get rid of the parentheses in the numerator. But leave the denominator factored, right? Leave the denominator factored. So in the new, so I'm going to go ahead and write this, so the denominator. All right, now in the first numerator, if I distribute, what does that become? X squared 27x, okay? In that numerator, in the second fraction, what does that become?
X squared minus
10x. All right. Now I'm going to do what?
Make it 1.
Make it one fraction. So I'm going to say 9x squared minus 27x. And now I'm subtracting every term in the numerator. So what does that become? Minus x squared plus 10x. Now combine like terms. What's the numerator? Divided by x minus 10 times x minus 3. Okay, now here's the question. Factor, remember, you leave the denominator factor. Don't multiply this thing out. Because if you multiply it out and something's wrong there, you're not going to get full credit. Now, the numerator can be factored, right? Is it going to help you? No, so you can leave it like that. So you can leave it like this, or you can say, how would you factor the numerator? X times 8x minus 17 divided by x minus 10, x minus 3, but it doesn't help you. You can't reduce anything. So either one of these is fine. Okay? But if factoring does help you reduce, then you need a factor. Because you want your final answer reduced. You want your final answer simplified. All right, so that's 38. Right, so those are two ways that you could have written this. All right, now let's look at 40. You have 10 divided by 3n minus 4. Subtract 5 divided by 4 minus 3n. Now think, you have one like this in my math lab, and You have one like this probably on the worksheet. All right. Think about the LCD. Think about factoring. I can't factor anything. But don't say the LCD is 3n minus 4 times 4 minus 3n because it's not the least common denominator. What do you notice about those two denominators? They're opposites. All right, they're opposites. Now, what you want to do, since you notice they're opposites, is this. You want to factor out a -1 from one of those denominators. It doesn't matter which one. But it's a good idea to factor out the -1 from this one because this numerator is what right now? Negative. So you factor out -1, a negative divided by negative is going to be a positive. So I'm going to factor out the -1 from here. So if I factor out -1, I'm going to get -1. Now remember, -1 times -4 is 4, and -1 times a positive 3n is a -3n. But do y'all understand? I'm going to write like this, though. That this is this, right? And the reason I wrote it like this because this was 3n minus 4 as well. But that negative right here, you want to put in the numerator. So this 5 becomes a -5. So here's what I have. I have 10 divided by 3n minus 4, subtract a -5 divided by 3n minus 4. And now can I combine it as one fraction? Yes. And I know that 10 subtract a -5, 10 subtract a -5 is 10 plus 5, which is what? 15. Can I do anything else? No, you're done. So that's the answer. That's number 40. So notice when the denominators are opposites, you want to rewrite it. Like I just did. So I did one like that last class period and then another one. And I think there's one like that in your worksheet. So you got to make sure you use that approach. All right, 44. 44. Now you have x divided by x squared minus 4 minus 5 divided by x squared minus 4x plus 4. All right. So what are you going to do? Factor. Okay, the first denominator, how do you factor that? X minus 2 times x plus 2. There's a difference of 2 squares. The other trinomial, that's going to be x minus 2, right? Right. So let's find the LCD. Every factor you see has to be part of your LCD. So my first factor I see is x minus 2. How many factors of x minus 2 occur in this denominator? How many times does it occur here? 2. So how many do I need? 2. So I have x minus 2 squared. The next factor you see is x plus 2. How many do you see here? 1. How many do you see here? I need how many? 1. So there's your LCD. So now you're going to write 2 fractions with that denominator. Okay. All right, now we're going to write equivalent fractions. This is what I have. This is what I need. Do I have everything I want in this first fraction? What's missing? x minus 2. So I got to multiply this by x minus 2. What I do to the denominator, I have to do to the numerator. So I got to multiply the numerator by x minus 2 as well. Now look at the second fraction. I want to write equivalent fractions. I have x minus 2 times x minus 2. This is what I want. What's missing? So I'm going to multiply the denominator by x plus 2 and the numerator by x plus 2. So the numerator here becomes x times x plus minus 2, and this numerator becomes 5 times x plus 2. Y'all agree?
Yes.
All right, now think about what we just did in the previous problem, or the problem before that. We're going to distribute. Now don't multiply the denominator out. Leave the denominator in factored form. Multiply the numerators though. So this becomes x minus 2 squared times x plus 2. What's this numerator going to be?
X squared minus 2x.
Okay, and then you subtract, and then this fraction. All right, what's this numerator going to be?
5x plus 2.
Plus 10. All right, what's the next step? Well, y is one fraction though, right? Now, I wouldn't combine like terms just yet because I am subtracting more than one term. So what you may want to do is write out the terms first and then combine them, because you better not get plus 10. You better get a negative 10 at some point. So this really becomes x squared minus 2x, and then you're subtracting all these terms. So 5x becomes a negative 5x, a positive 10 becomes a negative 10. And now combine like terms. X squared minus 7x minus 10 divided by x minus 2 squared times x plus 2. Right. What should be the next step? Factor. Can I factor the numerator?
Yes.
How?
5 and 2.
What would that be?
X minus x minus 2, x minus 5.
Well, a negative 2 times a negative 5 is a positive 10, though.
Okay, so negative positive.
Yeah, one has to be negative, one has to be positive.
The 5 would be negative and the 2 would be
That's going to give us a positive 3x.
no.
You can't factor that.
Okay.
So you're done. That's it. Okay. All right, let's look at number 50. Well, actually, let's do 46 next. 46. 46. All right, you have 1 divided by 2x plus 2y. Subtract y divided by x plus y. All right, so what are you going to do? Okay, you can factor out a 2 in the first denominator. And that's about all you can do in terms of factoring the denominators. Now, what's the LCD? 2 times x plus y. All right, so you can always check. This 2 goes into the LCD, and the x plus y goes into LCD. So you're done. Now we write two fractions with that denominator. All right, and then we're going to write equivalent fractions. So 1 divided by 2 times x plus y is equivalent to itself. The denominators are the same, so the numerators have to be the same. So that's 1. All right, now let's do this one, though. The denominators are different. I have x plus y, I want this. So what's missing? 2. So I got to multiply this by 2 and this by 2.
So I'm gonna be 2y.
So 2y in that numerator second rational expression. Now I can write it as one fraction, right? What's going to be the numerator? Can you do anything else? That's 2y. Nope, you're done. Okay? That's all you did. All right, so that should help you a little bit more with those 14.4 worksheets that you've been working on. I think I gave you 2 of them. I got 2 of them. All right. Okay, now, next class, we're not done. We're going to look at something else, but next class period, we're going to do a few more like this. Now remember, this is on your test, right? Okay. Oh. No, I don't think it's on your test. What does the study guide say? It's up here if you didn't pick it up.
It is 14.3 part C.
14.3? All right, so this is not on your test, right? Okay, all right. So this is on test 4, though. And test 4. So we're going to do a few more with this next class period. All right, now let's look at this, though. Now remember, you got to practice more with this because section 14.5 is where you're given a rational equation. So now you're going to be this is just going to be part of an equation, and you got to solve for the variable. But we're not going to do that right now. We're going to do that Thursday of the day after your test. What I'm going to do now, though, is start looking at radicals. What we're going to look at today is going to be the easy kind. So this is section 15.1. And let me go ahead and actually